Now I will say it would be interesting for you to use a lap timer. Excuse the gesture there, there's a fly. To use a lap timer and time various lengths of a pendulum yourself and see if you can get a lesser standard deviation. If you have younger reflexes and might well be able to improve in this. Of course, I'm fairly experienced with timing things, so you might be at a disadvantage without a little practice, but maybe not. If you time it carefully, you can probably do better than I did. Okay, in any case, now here's our graph of the three pendulum lengths versus, well, the three periods versus the pendulum lengths. And we have three error bars here, 3 points kind of in the middle of the error bars. Now, this graph, the horizontal axis isn't all that horizontal, vertical axis isn't all that vertical, and the camera at this angle isn't all that linear. So there are lots of reasons this graph isn't going to give us excellent results. We would use mathematical software or a very careful plot ultimately to analyze data of this nature, but right now it's important for us to do it by hand to reinforce what's going on, cause us to think about what's going on, and get a better feel for what's for what this represents. Now, I know that a pendulum of length 0, well, we're going to assume that the limiting period of a pendulum as length approaches 0 is 0. Okay, that's actually true. And we haven't proven that assumption, so we're kind of making a leap with that idea. And I'm going to draw then a graph through these points. I'm going to do my best to draw a nice smooth graph through these points. I've got one shot at this. I don't want to have to redo this. So choking up here. Okay, here we go. Okay, I think that graph should work pretty well. Now, what could we do with that graph? Well, first thing we want to do is go ahead and test whether, excuse me, I just caught that fly. Okay, he's dead. I have to slam him on the floor, and I'm getting old enough that's hard to slam hard enough to stun the thing, but he almost flew away, but I got him. Okay, and excuse that little bit of local color, but okay. So we want to test this graph to see if it's plausibly a power function. Now we could, of course, just take this point, and this point, which are practically double the y values, and we could look and see if the factor between this period and this period is the same as the factor between this period and this period. And we would find that that factor is about 1.4, and it's pretty close. But we don't want to use our data, we want to use our curve. And of course the curve isn't going to come out quite as nicely as our data might. Just estimating 3 points on this curve, I'm going to choose a point. Well, I'm going to choose an x value here so that my y value is represented by the length of this segment. I'm going to cut that distance in half. I think that puts me about here. Let's see, there and there. No, actually closer to here. Actually, it looks like my 48 isn't quite half of my 96. So that's just one of the inaccuracies of the graph. I'm going to fudge that just a little bit. Okay, so I've got this, and then I cut that distance in half. Now let's see, half of that distance ought to be about here. Boy, I thought I'd done a pretty good job in this, but I don't think I did. So I'm going to say that's about here. Now those points are real close to our data points, so we're not going to get outstanding results here, but Okay, I take this distance and I project that distance over here, something I'm apparently not very good at. And then I take that distance and add it up here, so I've got 1 times this. Well, let's see again. I took this distance, projected over here, took that distance, put it on top of here. So here would be a factor of 1. In other words, this distance here is 1 times this, and then this distance from here to here is 2 times this. Meaning that if the y value had doubled, the point would be here. If the y value had changed by a factor of 1, in other words, it hadn't changed, we would be here. So where are we here? Well, I think half of this distance is about here, maybe a little less. So that does look like a factor of about 1.4. I can do the same thing here, try to stay out of the way. We come over here, that would be what we'd have with factor 1. If I take this and double it, I end up about here. Looks like I actually did that one right. And then if I cut this distance from here to here in half, I get something about like this. Let's see, here, here, yeah. So that would be a factor of about 1.5. And again, it looks like our factor appears to be 1.4. This is just using an honest but flawed attempt. I still get about the same factor. Now, if you had this graph drawn very carefully, you could do similarly. We could even test to see how I did with this part of the graph. We could cut this distance in half and project up to here. I don't know how I did there, but here and here, that looks like it's pretty close to halfway. That factor looks like about 1.5, but there are a lot of uncertainties here. So it appears quite plausible that what we have is a power function graph. Now, at that point, I went to software and calculated things. So I'm going to give you the results of those calculations and those trend line fits.